Everyone, welcome back to Tutor Corner LLC, and today we are going to cover linear functions. Now, everything that we have been doing in terms of solving for x in various ways, in one-step, multi-step, with distributive property and combining like terms, has led us to this. Because in this, we will learn how to apply solving for x in a function. So now, if you would like some review on solving for x, in multi-step equations, combining like terms, and the distributive property, please go to my channel, Tutor Corner LLC, and click on the previous videos. So, a linear function is represented in the format of y equals ax plus b. A visual representation of this is you have your inputs that goes into this sort of machine. Let's just maybe call it a black box, right? And whatever comes out are the outputs. One way to represent this mathematically is the input being the x values and the output being the y values. And whatever happens inside this black box, that is the function. Okay, so this is how we can relate x with y and how it all ties into this black box that creates the function in which it turns the inputs into outputs. Now let's think of the formal definition in mathematics. A function is a set of x values to a set of y values in which each x value results in exactly one y value. Okay? So let's try to think about this and hopefully better understand what it is that it's trying to say here. Okay? So let me just zoom out for a second here, and we're gonna try to talk about it. So let's create a list of inputs and a list of outputs. Let's say number 1 or 0, sorry, goes into this black box. Okay, I'm gonna delete it just for clarity's sake. We have the number 1, number 2, and the number 3 as inputs. Now, inside this is the function. And we know that 0 maps into 1. Let's assume that, and 1 maps into 2, 2 maps into 3, 3 maps into 4. Now looking at the definition, a set of x values to a set of y values in which each x value results in exactly one y value. Does this 0 result in exactly one y value? Yes. This 1 to 2, so yes. This 2 to 3, yes. This 3 to 4, yes. So we can call this entire thing a function. Okay? So let's give another example. Example 1, in which we have a set of inputs 0, 1, 2, 3, and we have outputs 1, 2, 3. Okay, let's assume that 0 maps into 1, 1 maps into 3, 2 maps into 2, and 3 maps into to 3. Okay? How do we determine if this is a function? Now we would have to go back to this definition once more, a set of x values to a set of y values in which each x value results in exactly one y value. So 0 maps into 1. Is that one y value? That is correct. So we are good. I should probably put the check mark on this side. So 0 we are good for. 1, does it map to just exactly 1? That is correct. It maps into 3. 2 maps into 2, 3 maps into 3. So yes, this thing is a function. Okay? I know it seems a little odd that 2 arrows point to 3, but think of it this way. You will see in the next example, there's a little trick that I use to better understand or visually understand what's going on, if it is or isn't a function. Okay? So this is a function, because there's only one arrow coming out of each one. Example 2. Let's say you have the x values or the inputs, -2, -1, 3, 4. And you have the y values, 0, 1, 2, 3, 4, 5. Let's say -2 maps into 0, -1 into 1, 3 into 3, 4 into 2, -1 also maps to -4, and 4 maps to 5. These are the y values or outputs. Now, remember, the definition of a function is that each x value maps to exactly one y value. All right, let's go on to our checklist. Let's see. -2, does it map to 0? Yes. Is that the only thing it maps to? Yes. So we are good for -2. -1, you see how it maps to 1? And it also maps to 4. So does it map to exactly 1? So no. Now, we can check the whole thing, but right there we can stop, because that tells us that that rule has already been violated, meaning that this system is not a function. Now, the little trick here that I use is I normally just use these numbers on the left side, and I try to see and make sure that each number only has one arrow coming out of it onto the right side. Now, as you can see here, -2 only has one arrow, whereas -1 has two arrows pointing to two different numbers, 1 and 4, and that's why it's not a function. Okay? And you're more than welcome to pause this video if you would like. And moving on to the first example right here, as you can see, right here, it is a function because there's only one arrow coming out of 0, one arrow coming out of 1, one arrow coming out of 2, and one arrow coming out of 3, so it is a function. This one, the same case. One arrow coming out of 0, one arrow coming out of 1, one arrow coming out of 2, and one arrow coming out of 3, hence a function. Okay, so we'll do one more example to make sure that we have solidified our knowledge of these kinds of determinations for functions. All right, so let's say we have a list of x values in which our x values are -4, -3, -2, 1, 0, and y is -1, 0, 1, 2. Okay? All right. -4, let's say, maps to 0. -3 maps to 2. -2 maps to 1. 1 maps to -1. And 0 maps to 2. Does -4 map into exactly one number? Yep, one arrow coming out of there, so it's good. To -3, one arrow coming out of there, it's good. -2, one arrow. 1 also has one arrow coming out of it. 0 also has one arrow coming out of it, so it is a function. Does that make sense? We'll do one more just to make sure that we understand it. Okay, so you're more than welcome to pause this, by the way. Example, I believe we're on example 5. So let's say you have x values of 1, 2, 3, 4. And then you have y values of 0, 3, -5, -2, -1. 1 maps to 0, 2 to -2, 3 to -1, 4 to 3, and 2 to -5. One arrow coming out of 1. Right there, 2 arrows coming out of 2, pointing into -2 and -5. So 2 maps into 2 different numbers. So it's not a function, and we don't even need to check the whole list because that tells us it's not a function. Now, this ends our quick little video tutorial for today. Now, if you have any questions, please don't hesitate to leave a comment down below, ask questions, and also tell me some recommendations or things like that. And once again, don't forget to hit like and subscribe for more free content to watch on my channel. Thank you.